4.3. And 4.3 is about properties of logarithms. So we studied in section 4.2 the logarithmic function and logarithmic functions, and now we need to study some properties of logarithms. We studied already some properties, if you remember. We said that log 1 to any base is 0, log BB is 1, and also a relation between the exponential and the logarithmic, which is log x to the power b, or log b to the power x to the base b as x. يعني log والexponential cancel each other. Now we will study three important properties. They are really called properties of logarithms. The first one is the product rule. Try to understand what we mean by the product rule. Okay. We mean by the product rule, if you have log m times n, so this is product, okay, to any base, you can write this as log m plus log n. So please try to understand this rule carefully. In the left-hand side, you have one log. Inside the log, you have product. In the right-hand side, you have two logs and some addition. And m is inside one of them and n inside the other one. So for example, ln 7x would be equal to ln 7 plus ln x. This is an example of the product rule because 7 is multiplied by x. So that's the product rule. So here, use the product rule to expand. You can write it log 100 plus log x. And if you remember, log 100 is 2. Why? Because the base here is 10, and 10 to the power 2 is 100. So log 100 is 2, so the answer is 2 plus log x. While here, you can write it log 7 to the base 5 plus log 3 to the base 5. This is the product rule. Okay, the second rule is the quotient rule. Quotient means division. Okay, we have a fraction. So look to the rule and try to understand it carefully. Log m over n. Now this time, inside the log, you have quotient or division, m over n. And notice again that in the left-hand side, you have one log. In the right-hand side, you have two logs and subtraction. So whenever you have log m over n, you write it log m minus log n. Because we have two logs in the right-hand side, the question will be always expand. Expand means make something bigger. So here you have one log, you made it two logs. So this is expansion. Okay, but the question would be always expand. So how to expand log x over 2? Log x minus log 2. And the base here is 10. This is a common logarithm. Okay, this is an example. Log 19 over x would be log 19 minus log x to the base 7. Len e cube over 7 would be len e cube minus len 7. Remember, there is a formula, len ex equals x. So len e3 would be 3. So you can write this as 3 minus len 7. Let us solve these two questions. Part A, okay, would be log, I have log 23 over x to the base 8. So it would be log 23 to the base 8
minus
minus log x to the base 8.
8.
Part B, it would be ln e to the power 5 minus ln 11. And remember, ln ex is x, so ln e5 is 5. So the answer would be 5 minus ln 11. This is expansion. Notice the question, use the quotient rule to expand. He may say expand without using the quotient rule. Good. So there are two rules up to now. The product rule, the quotient rule. The third rule is called the power rule. Okay, the power rule. It means that we have something in the power. Yeah, try to understand here. What do we have? We have P in the power of M. So please understand this carefully. Here you have P as a power of M. It is not a power of log. Okay, it is not a power of log. يعني this is not log مثلا log 3 to the base 2 to the power 2. This is not equal to log 3 2 all to the base 2. There is a big difference between this one and this one. Here 2 is a power of 3 only. Here 2 is a power of all the log. يعني it means, if you understand what is the meaning of powers, the left hand side is log 3 times 3 to the power 2. So you can write it log 3 plus log 3. While the right hand side is log 3 to the base 2 times log 3 to the base 2, because the power is power of logarithm, the log. So pay attention. The 2 is a power of m. The p is a power of m. Yani what happens if the power is a power of the logarithmic? We don't do anything. There is no rule, okay? There is nothing. You cannot simplify this. You cannot expand this. But you can expand the left-hand side. How? You can bring p outside. Bring p down in front of the log. So you can write log m to the power p as p times log m. For example, ln x to the power 2, you can bring the 2 out, 2 ln x. You have to pay attention يعني, to this example, okay? If I ask you, is now ln x squared is equal to 2 ln x. That's correct. But what is x here? What is x? Okay. For the right hand side, يعني if I ask you y equals ln x, what is the domain? If you remember, the domain from 0 to infinity. But y equals ln x squared, what is the domain? If you remember also, we solved a question like this. From negative infinity to 0, union 0 to infinity. All numbers except 0, because this is x squared, always positive. Like in here, we need to make it positive, the domain from 0 to infinity. So the domain of these two functions is different. The domains are different. So ln x squared will be equal to 2 ln x only if or for x greater or belongs to 0 infinity. If x is from 0 to infinity. But if x is from negative infinity to 0, yani if x is negative, then this statement is not correct, because ln negative is not defined. So pay attention to this. Here, he mentioned it here. He said ln x squared equals to 2 ln x only for x greater than 0. Also, you can think, or you can see the graph. Look to the graph. We said that the domain of ln x squared, all real numbers except 0. So you can see it in the graph. See, this is the graph. This is the graph of ln x squared. you have a graph to the right and a curve to the left, and x equals to 0 is a vertical asymptote. So the domain all real numbers except 0, because x square هنا x could be positive or could be negative, for the graph is like this. طبعا this is not a one-to-one function. While ln x, this is the graph of 2 ln x. It is similar to the graph of ln x, but there is a vertical stretching of 2. فالدومين هنا 0 to infinity. وبالتالي you must know the difference between these two functions, ln x and ln x square. Okay, some examples about the power rule. Here, you can take 4 out, so you can write it 4 log 7 to the base 5. Here, you can write square root of x as x to the power half, and then you can take the half outside by the power rule. Here, since 5 is a power of 4x, all of it, so you can take 5 outside, so you have 5 log 4x. So these are some examples about the power rule. Here, for example, you can expand this. You can write it 2 times log x plus 4. And here, you can write it negative 6 log n, capital N. طبعا notice an important remark. Log x plus 4 is not equal to log x plus log 4. This is not correct. There is no rule like this. We have the product rule. This is not the product rule. We have the quotient rule. This is not the quotient rule. And we have the power rule. And this is not the power rule. So there is no rule for this. This is not correct. And you can easily use the calculator to check, for example, log 6 plus 4 to the base 10 is not really equal to log 6 plus log 4 to the base 10. The calculator will give you 1 here and this side, and here, I don't know, some other number different than 1. These are not equivalent. Please pay attention. The last point today will be objective 4. How can we use these 3 properties together, the 3 properties together, to expand the logarithmic expression? So the question here would be expand logarithmic expression. So we expand logarithmic expressions by writing log m times n as log m plus log n. We expand by writing log m over n as log m minus log n. We expand by writing log m to the power p as p log m. Okay, this is a great question here. This is what I told you. Ln x plus 3 is not equal to ln x plus ln 3. This is not correct. So if you write log m plus n equals log m plus log n, immediately 0. This is not correct. Don't use it, please. This is the graph of ln x plus 3. What happens? 3 units to the left. It is similar to the graph of ln x, but you take the graph 3 units to the left. While this one, ln x plus ln 3, it is the same as ln x, but there is a vertical shift. And you move the graph ln 3 units up. فالasymptote here for this x equals to 0, vertical asymptote, while the asymptote for this one is x equals to negative 3. So the two functions are not the same. These two are not the same. Please do not use this because it's not correct. Okay, let us solve some examples about expanding. The question would be expand. How to expand? Okay, you will have 1 log. Usually in the question expand, you have 1 log, and inside this log you have some powers, product, division. Then you can use the 3 properties, these properties, to expand. Okay, please wait until the end. Okay, so here the product, we change it to addition. So you can write it log x squared times log square root of y. But remember that square root of y can be written y to the power half. Okay, he did not change the product. He just changed here square root of y as y to the power half. Then he used the product rule and he wrote it as log x squared plus log y to the power half. Then he used the power rule and take 2 outside and half outside. So this would be the final answer. This is the expansion. Let us see the other question, the second question. Here, the beginning of the question, we have 1 log, okay? You can write cube root of x as x to the power 1 over 3 first, and then you have a division, quotient, and multiplication in the denominator. So do it step by step. Use the quotient rule first. So we write it log x to the power 1 over 3 minus log 36y to the power 4. This is the first step. Now the second step, we can use the product rule here, because here we have product. So we write it log x to the power 1 over 3 minus, and inside parentheses, these parentheses, okay, log 36y to the power 4 is log 36 plus log y4. Notice that the minus sign is outside all the parentheses, okay? So now you take 1 over 3 down here and take 4 down using the power rule, and now you distribute the negative sign. So 1 over 3 log x minus log 36 minus 4 log y to the base 6. Remember, log 36 to the base 6 is 2 because 6 to the power 2 is 36. So log 36 to the base 6 would be 2. So this is the final answer. Let us solve these checkpoints. Okay. Part A here. Expand. The question is expand. So I will do it like this. Log x to the power 4 to the base b plus log y to the power 1 over 3 to the base b. And then I use the power rule for log x to the base b plus 1 over 3 log y to the base b. Part B, I have quotient. I can use the quotient rule first. So I will say log x to the power half to the base 5 minus log 25y cube to the base 5. This is using the quotient rule. And now I can use the product rule and the power rule at once. If I will write it, half log x to the base 5, بعدين I will have minus log 25 to the base 5, بعدين the minus will be also multiplied again, and I will have log y cube, or if you take the 3 outside, you can write it 3 log y to the base 5. Finally, you can notice that log 25 to the base 5 is 2, because 5 squared is 25, and this would be the final answer. This question is the same question, I think. Yeah, it's the same question, so you can try by yourself. Let us do this one. Expand. So again, I have a quotient. So I will write it log 36 to the base 6 minus log x plus 1 to the power half, which is square root of x plus 1 to the base 6. And now I can use the power rule, and I can use the fact that log 36 to the base 6 is 2, because 6 squared is 36. So the answer would be 2 minus half log x plus 1 to the base 6. Here, some examples, some questions. Question 11. All the questions here, if you notice, expand. and where possible, evaluate. Evaluate means log 36.6, you write it too. Okay, so question 11. I think you can do it by yourself. It is easy. We did question 21. Also, this is easy. It will be 2 log x plus log y. Also 23, 27. 23 we did like it. 27, let us do 27. Okay, log x square y over z square. Log x square y over z square to the base b, to any base. Okay. Expand. The question is expand. So we have one log. I can solve it immediately in one step. How? You can do that. It's no problem. You use the product rule here, and let us do it step by step. Okay. Log x square y b minus log z square b. This is using the quotient rule. Then I can use the product rule. Log x square b plus log y to the base b minus log z square to the base b. Third, I can use the power rule. So 2 log xb plus log y to the base b minus 2 log z to the base b. So here I use the quotient, then the product, then the power rule. 31 and 33, I solved a question similar to 30 to 31. Well, it is not similar. So let us do it. Let us do one of these. I will do 31. Okay, log cube root of x over y. So 31 log cube root of x over y. Okay, to the base b. How do we expand this? We have one log. How to write it more than one log? The first step to do here is you cannot use the quotient rule. You cannot use the quotient rule because you have a cube root. So the first step is to write it x over y to the power 1 over 3. Then use the power rule. You use the power rule to bring the 1 over 3 down. And then now you can use the quotient rule. Log x over b minus log y over b. And finally, you can distribute 1 over 3. The answer would be 1 over 3 log x to the base b minus 1 over 3 log y to the base b. Some more questions. Okay, 35. This is 35. Similar to what we did now. Okay, with 31. Let us do it also. 35. Log cube root of 20 x square y over 25. X square y over 25. Expand. So first, what is the base? The base is 5. Okay. The base is 5. So first step is to write x squared times y over 25 all to the power 1 over 3. And you use the power rule to write 1 over 3 outside, okay, to the power 5. And now you can write it 1 over 3 times. Now you can use the quotient rule. The quotient rule, log x square y to the power 5 minus log 25 to the base 5. But then you can use the power rule and the product rule if you like. So you can write it 2 log x to the base 5 plus log y to the base 5 minus log 25 to the base 5 is 2 because 5 squared is 25. And finally, you expand, you distribute, you multiply 1 over 3 by all the terms. So you get 2 over 3 log x to the base 5 plus 1 over 3 log y to the base 5 minus 2 over 3. This would be the final answer. 39, okay, 39 is complicated. Let us do it together. This is the most complicated question, and it would be the last question. So it is log, okay, and we have the good thing here is that the base is 10. 10x square, 10x square, cube root of 1 minus x over 7 times x plus 1 or square. Okay, so this is the question. Let us expand this. You can do it one by one, step by step. So the first step is to use the quotient rule. If I will have log 10x square cube root of 1 minus x minus log 7x plus 1 to the power 2. This is using the quotient rule. Okay, now let us continue. Now I will use the product rule in the first term, the product rule and the power rule. So I will write it log 10 plus, let me use the log x square, the product rule only, plus log, I will write 1 minus x to the power 1 over 3. And there is a minus sign here, and you open parentheses, and you write log 7 plus log x plus 1 to the power 2. And now log 10 is 1, and this is 2 log x, and this is 1 over 3 log 1 minus x, and here minus log 7 and minus 2 log x plus 1. By this I come to the end of this lecture, and if you have any question, you are most welcome